let's do an example. Let's actually do a computation here. So we're going to let our f of x, y, z, our multivariable function is going to equal x squared, y to the third, plus z to the fourth. And we're going to specify that x is equal to s squared, y is equal to st squared, and z is equal to s squared t. Okay? Alright, so what we're going to do, here's the problem. We're going to compute the f dt, partial f, partial t, using the chain rule. Okay, so we're given all of these things. So this is our outer function, the f of x, y, z, and these each are our like our mini inside functions. Like they determine our path, right? So this first one is our x of s and t. Even though we don't see a t here, we could assume that t is to the 0 power or something. And then our y is actually, we see both an s and t, and z we see both an s and a t. Okay? So what we're going to do is start with the chain rule. So how would we compute partial f, partial t? Let's write down the formula for that. So that would be equal to partial f, partial x, partial t, plus partial f, partial y, partial t, partial f, partial z, partial t. Okay, so there is a pattern to this, and after you write it a couple times, then you'll just get used to it, and it'll become, hopefully, like second nature to you. But anyways, so now that we've written this is the chain rule, okay, for computing our partial f, partial t, and now let's just find each of these partials and we'll plug them in. So first of all, let's do the primary derivatives. So partial f, partial x. So that means we're going to look at our top function up there, okay? So our f of x, y, z, and we're going to differentiate with respect to x, okay? So what that means is that our z term is going to go away because it's just by itself. That's a constant. And then we're going to get out a 2x and then a y cubed, okay? And then let's do the next primary derivative, which is partial f, partial y. So that's going to be, if we're considering y as the variable, we're going to get a 3x squared, because that 3 comes down in front, and then a y squared is left over. Okay, and then the z term, again, that just goes away. And then finally, our last, that's a z. Partial f, partial z is going to be, this xy term goes away, so we just get a 4z cubed. Okay? Alright, now for the other set of partials, we're going to go more in detail, and we're going to get to the t's. So we're going to do partial x, partial t. So now we're going to look at the other set of equations. So first of all, we see that x is equal to s squared, which there is no t, right? So that just means that our s squared, which is considered a constant, that's going to be a 0 when you derive it. Okay, the next one is going to be partial y, partial t. And let's look at that one. So we have y equals st squared. So if we're considering t the variable, we're going to bring that 2 down in front, 2st, and then subtract 1 from the power, so we have t to the 1. Okay, so we have 2st for that one. And finally, we have partial z, partial t. So if we look at that guy over here, this is s squared times t. So our s is considered a constant, so we're just going to bring out that coefficient, which is an s squared. Okay, so these are all of our partials. We have 6 of them here, and we're just going to plug them into this equation that we already found. Okay? Alright, so partial f, partial t is going to equal, alright, so for partial f, partial x, well, I'll just write it down here so you guys can follow along. So I'll just write it pretty quickly. Okay, partial f, partial y, partial t, partial f, partial z, almost done, partial z, partial t. Okay, so if we plug in what we had, this is going to be, so partial f, partial x was a 2x times y to the third, and then partial x, partial t, there was no t in the x formula, so that was a 0. And then we have plus partial f, partial y was equal to a 3x squared, y squared. Okay, and then partial y, partial t was 2 times st. And then we have plus, this last term is going to be partial f, partial z, which was 4z cubed, and then partial z partial t, which was an s squared. Okay, so this first term we see that just goes to 0, so that goes away automatically. That's good, one less term to deal with. And then we have these terms left over, right? So let's write those down. So we have the 3 and 2 combined to make a 6, and then we have x squared, y squared, st, and then plus a 4 times z cubed times s squared. So this, we kind of have a bunch of variables just mixing around here. So what we're going to do is put everything in terms of s and t. Terms of s and t. Okay? And we're going to use the fact that our original equations were x is equal to s squared, y was equal to s times t squared, and z was equal to s squared times t. Okay, so we're just going to plug in all of these things wherever we see an x, y, or z. So our partial f, partial t is going to end up being 6 times x squared, so now that's s squared, times a y squared, which is st squared, right? And then our st was just sitting there, plus 4z cubed. So z is now s squared t, and all of that is cubed. And then we have our s squared there. Okay? So now what we're going to get is that we have partial f, partial t is equal to, and that 6 still stays there. Then we have an s to the 4th, an s to the 2nd, t to the 4th, and an st. Okay? And then plus 4s, and that's to the 6th power, and then t goes to the 3rd power, and then we have an s squared. Okay, so our final answer is going to look like, so we're just going to add up all these exponents. So s, in this first term, we have s to the 7th power, and a t to the 5th power. And then we have plus, and we have 4s to the 8th power, and t to the 3rd. Okay, so that's basically our final answer right down here in the corner.